let's say this is velocity time graph, right? So if I ask you, like, let's say I'm going at 60 kilometers per hour, right? I'm going for 1 hour and this is 2 hours. So if I ask you what is the distance traveled, how do you find it? Velocity into time, right? So distance is equal to velocity into time. So 60 into 2 will give you 120 kilometers. So very simple, right? So you would say it is 120 kilometers. You don't need a graph, you don't need a calculator, you can quickly say that, right? Even when you are traveling, you can calculate this, right? But if you had a situation like this, if the velocity is kind of, changing, right? Or let's say, even worse, suppose if you had a curve, something like this, right? So if something is changing like this, right, then you need the concept of integration, okay? So we say that you take a small region here, take it as say dt, right, and this is v, right? So if I want the area of this, what should I do? V into dt, but that is only for this small strip, right? So if I want this total area, what should I do? I should integrate from here to here, meaning I should find small area here, small area here, small area here. So I have to keep on adding all the area, right? So that's what we call it as, integration. So integration is nothing but integral of v dot dt. So you have to keep on adding all these small regions and add it from 0 to t. So suppose if I give 0 to 5, I have to add it from 0 to 5. Okay. So again, this is a very oversimplified introduction, right? But that's the best we can do right for now. So hopefully when you are studying it in maths, probably it will make more sense. Okay, so we have separate chapters for integration. So always remember, differentiation means slope, integration means area. Okay, so that's what you have to remember. Okay, so take down this. And then we have very important derivation. This is a little bit, it's kind of easy if you understand the concept, but it's 3D, right? So it may take some time for you to understand this. Yeah. Adya, Namrish, what's going on? So suppose if I take a conductor which is in a circular form, right? So we are going to derive something of this. So they will ask you to derive the magnetic field on the axis at a given distance of x. And this radius here, let's say it is given as a. Okay. So how can I show this properly? So imagine I have a current carrying conductor, something like this, and it is kind of wound across in a circular form. So I need to have something like a ring or something. Okay, so imagine I have a circular loop like this, right? It's carrying some current. Okay, so actually it's kept like this. Okay, but in the paper, in the board or paper, you cannot show it like this, right? So we have to show it something like this. This is what makes it very hard to understand. Okay, so the entire thing will be like a 3-dimensional thing. So actually it is kept like this, but we are showing it like this. because we cannot show the 3D properly, right? So coming back to this, we are going to consider a small dl here and a small dl here. So meaning you consider a small dl here and small dl here, okay? So if I have a dl here, right, it's going in, this is going into the paper and this is coming out of the paper because the current is flowing like this. So this is dl and this is dl here, right? We are considering small 2 dls for now, okay? So let's say the current is flowing like this, I. You want to find the magnetic field at this point P. So how can I explain this? So suppose if I take this as dl, right? Imagine that this block is dl this way. So there will be a r from here to here, right? So dl is coming out of the paper, right? As I told you, it is coming out of the paper. So this is out of paper, this is into the paper. Everybody following that? So dl is this way, right? And r is this way. So r is actually going this way. So dl is this way, r is going this way. So dl cross r. So what are you supposed to do? You start your fingers at dl and go to r. So dl cross r. So look at my thumb. So it will be going this way. So what did we say here? Direction of B magnetic field is perpendicular to dl and r. Okay. So if I do this, it will be going something like this. So it will be perpendicular to this. This is the difficult part. So make sure you are understanding this. Even though the dl is shown like this, what I am trying to tell you is dl is not like this. dl is actually coming out of the paper. Everybody following that? Because I cannot show the 3D in the 2D board. So dl is coming out of the paper. R is this way. So dl cross r. So look at my. So dl cross r. So look at my thumb. So it will go like this. So this will be 90 degree. Okay. So if you understand this, this is very, very easy. If you don't understand this, you will be struggling a lot. And look at this. The bottom part, we said dl is going into the paper. So instead of coming like this, it is going into the paper. Okay. So dl is here. So dl is going into the paper and r is somewhere here. So look at this. dl. So I should start from dl and then go to r. So dl cross r. So it will go something, your thumb will go something like this, downwards. You following what I am saying? So here it was the other way. So dl cross r. So thumb was going this way, 90 degree here. Same thing here. So this will be going dl cross r. So it will go 90 degree this way. What it means is the light is inside. So what it means is due to this dl, the magnetic field produced is this way. Due to this dl, the magnetic field produced is this way. Right? That's what I said, a small dl is producing a small magnetic field. And at the end of the day, everything will be added together here, and that will be your total magnetic field. Okay. So I am taking this as phi. So this is phi, this is also phi. Right? So if I draw a line like this, that one required? Okay. So if I draw a line like this, carefully listen. This line and this line are 90 degrees. So this is phi. What can you say about this one? 90 minus phi. If this is 90 minus phi and this are 90 degree, what can you say about this one? That must be phi. Following that? Okay, so if you have doubt, make a small note in your pencil or something. It's not required, because if you write too many things, it will become very busy. You will not be able to understand what is important, right? So maybe write this in a pencil. So this is phi, this is 90 minus phi, because this is 90 degree. But you know that this and this are 90 degree, which means if this is 90 minus phi, this has to be phi. So based on the same logic, I can say this is also phi. So now I am going to resolve this vector into two vectors. So if this is dB, right? What can you say about this one? Will it be dB cos theta or sin theta? Sin phi or cos phi? Cos. Why? Because it is adjacent, right? So since it is adjacent, you would take it as dB cos phi. Same thing here. What about this one? This would be dB sin phi. So this can be, maybe I can write this again here. So dB, so this is dB cos phi, right? dB cos phi, because this is phi, this is also phi, and this would be dB sin phi due to this one, and this will also be giving another dB sin phi, so I can put one more arrow, dB sin phi. Sorry folks, following this. So understanding the diagram is very, very important for this derivation. Okay. So the only part where you will have trouble is getting this angle because of this cross. And if you remember, this is 3D, right? This is not 2D here. This is 3D. So you have to understand DL is coming out here. So DL cross R will go like this. DL cross R will go like this. Okay, that's the difficult part. After that, it's all easy. What can you say about this and this? It will cancel each other, right? Because it is in the opposite direction, right? Which means it will cancel. Okay. So this DL is producing a dB here. What we saw was this and this are getting cancelled out. So what is effective? Only this one, dB sin phi. Okay. So because of this DL, only this dB sin phi is actually effective. What I am trying to say is, if I take this DL and this DL, I am seeing that this and this are getting cancelled out. If I take a DL here and here, so similarly the sin cos phi will cancel out. Only the sin phi element will be there. Are you following what I am saying? So all the y components will be cancelled out. Okay. So there will be only x components. Each one, this and this, you can say that all the cos phi's are going to cancel each other. That means one DL is going to contribute only d phi, that too in the direction of the axis. Okay. Mu naught by 4 pi I dl sin theta by r squared. So dl is this way, r is somewhere this way. So try to imagine this. As I said, only this 3D thing is very, very confusing. Okay. So if you have that idea, you will understand this very well. So dl is this way and the r is this way, right? So what can you say about the angle between them? 90 degree, right? You see, you cannot understand this way, but when you turn it and see it, it will be 90 degree. Okay. So that means the angle between DL and R is actually 90 degree, even though you don't see it here, because the diagram is not the way it's supposed to be because of the 3D thing, right? So only if you think with some pens, you'll be able to understand it. So that means I'm going to say theta angle between dl and r is equal to 90 degree. So sine 90 becomes 1. So I'm just going to skip that, quickly write that as 4 pi I dl by r square. So the dB value is given as mu naught 4 pi I dl by r square sine 90 is equal to 1. Okay. But my target right now is to find out the total magnetic field at this given point. Okay. So in your question they gave you a radius a, they gave you the current flowing through the conductor which is I, and then they said okay, so if this is so let's say 10 amps current is flowing through this conductor and the radius is, let's say, something like 20 centimeter or something, right? And if I keep a point somewhere in the axis, something like 30 centimeter, so you are given a, x and I. So you are supposed to find the magnetic field at that particular point. Okay. So we already got some idea here saying that all these things are cancelling out, which means only dB sin phi is there for a given dl. So for a small dl, I am producing a small magnetic field of dB sin phi. Okay. So based on this, I can say small dl produces a small magnetic field dB sin phi. So one dl is producing this one, another dl is producing this one along the direction of axis. Okay. So now the concept is in the integration, what we do is, if I find for small dl, right, I can integrate it for the entire circle, right? So if I say because of this I am getting 5 units of magnetic field, then if I calculate for all the dl together, right, I can calculate the total magnetic field. So that's the principle of integration. Okay. So now I can say if I want the total magnetic field B, so total magnetic field B at given point is given as dB sin phi. So this is due to one small dl. So if I calculate for the entire circle, right, so I have to integrate for, so like this I have to integrate for all the dls. So that's the meaning of this. Okay. So I'm 100% sure that it's not going to be easy topic. Okay. So if you don't understand, don't worry. If you have any difficulties, let me know. Okay, raise your hand and let me know. I can repeat it. Any issues? Any part which you find difficult? You come 1 hour late, that's what happens. Okay. So that's a constant. So, okay. So we are more concerned about something else here. That's just a constant. You can take down the notes. Okay. So just like your 1 by 4 pi epsilon naught in your previous chapters, right? This is magnetic field. Okay. So due to a small dl, I am producing a dB sin phi. So if I want it for the entire circle, entire loop, then I have to integrate it. That's the meaning of this. So I have to integrate it from, so in circle integration, what should I say? I should say from 0 to 2 pi, right? So it's 0 to 2 pi radians. But dB, I found the value as this one, so I'm going to substitute it here. So mu naught by 4 pi I dl by r squared sin phi. So you integrated 0 to 2 pi, right? So integration rules, I think formulas you will be studying later in your maths. Okay. So for now you just have to understand that mu naught by 4 pi is a constant, I is a constant, right? So I can take that out. So dl by r squared alone will be sitting inside. So look at this. So let me write it here. So mu naught by 4 pi, take it out. I can also be taken out because current is also a constant. I am not changing. So if I am flowing 5 amps, it's going to be 5 amps. If I am flowing 10 amps, it will be 10 amps. So it's a constant. So constants can be kept outside. Only the changing things should be taken. So dl by r squared sine phi. From the diagram, can you say phi, sine phi? So this is phi. So what is sine phi? Sine phi is going to be opposite by hypotenuse, right? So it's going to be a by r. So I am going to say dl by r squared a by r. A is a constant, right? In the question it was given. So they gave you this radius, they gave you this distance in the axis, right? They gave you the current, but they didn't give you the r value. But if I am given with a and x, can you find the r? Yes, right? Simple Pythagoras theorem, right? So I can say r cube can be written as a square plus x square square root. Do you agree? So I can say dl here a by r cube mu naught by 4 pi I. So r is nothing but a squared plus x squared 1 by 2 power 3. In your exam, actually you can skip some of the steps, but here make sure everyone is understanding. So if this is a and this is x, this can be written as square root of a square plus x squared. So that's what I am writing. Instead of square root, I am just writing it as 1 by 2. And then there is a cube here. The question, what did I say initially? They gave us radius a, they gave us x, they gave us I, right? So a and x are given constants, right? It can be say 5 centimeter, 20 centimeter, 30 centimeter. So it's a constant, right? Which means, what can you say about this entire term? So the entire term is a constant, right? And this one, even though I have not written at every step, you have to write this. So 0 to 2 pi. So I am going to say mu naught by 4 pi I a divided by a squared plus x squared power 3 into 1 by 2 is 3 by 2, right? So integral of 0 to 2 pi dl. So integral of 0 to 2 pi dl is, what do you think the value for that will be? So look at this, I told you this is a small dl here, right? So if I integrate this small dl, if I add all these small dls, what will be the entire length of this? 2 pi r, right? Or 2 pi a. So because they are given the radius as a, right? So that means your entire length is going to be 2 pi a. Is that clear? 2 pi r circumference. So that means this is nothing but circumference of the loop. So mu naught by 4 pi I a by a squared plus x squared power 3 by 2 2 pi a. So simply simplify that, you will get the answer. So you have mu naught by 4 pi I 2 pi a square divided by a squared plus x squared power 3 by 2. So if you want, you can simplify this further, right? but generally I like to leave it like this. For your exam purpose, you can simplify this. So what did we find? We found the magnetic field. So this is your final answer. So in your exams, I recommend you to put some box like this. Okay, whether it is numericals or derivations, the final derivation or the final value should be boxed. So if you don't put anything, examiner has to keep on searching, what you have done. Okay. So numericals, if you do it very well, if the answer is correct, nobody is going to look into the structure. A by R. So A is here, X is here, phi is here. So what is sine phi? Opposite by hypotenuse. So A by R. Right? So if you want, you can write it down here. So sine phi is equal to A by R. Okay. So we may have to talk about the special case here. So what will be the special case? Suppose if I said this x is equal to 0, what will happen? If I say x is equal to 0, if I say x is equal to 0, it will be 0. If I say x is equal to 0, so I told you this is a loop, right? I told you x is the distance from the center here. So if x is equal to 0, what does that mean? It means center of the loop, right? So when you say x is equal to 0, we mean this point. So that's a special case. So simply substitute x is equal to 0, you'll get the answer. Write yourself. So the special case would be x is equal to 0. So magnetic field B at the center of the loop. B is equal to mu naught by 4 pi I. So x is 0 means you will get 2 pi a squared divided by a squared power 3 by 2. So 2 cancels, so a cube and a squared cancels, so I'll get a in the bottom. So mu naught by 4 pi I 2 pi a squared by a cube, so a squared cancels, so I will get a pi cancels, so I will get mu naught by 2 I by a. Yeah, you can. That's what I said, Generally, I like to keep it separately like this because this mu naught by 4 pi is a easy constant. Okay, so if you know this constant, you can simply put the value here and do it. Okay, so as you do some numericals, you will understand. It's easy to remember this way. If you cancel it, it's confusing. Any doubts so far? So this is the main derivation, right? So again, what is the question number here? 13. First case. The second case is instead of one loop, right? If we had n turns, right? So if you have n turns, you simply have to multiply that result into n, because imagine that the loop was not just one single wire. So imagine that you had a lot of wires like this. So that is second loop, that is third loop, right? So let's say you have like 3 or 4 turns, right? That will be your n. You simply have to multiply that n because it will be so many times, right? So the magnetic field is going to be so many times stronger. So I can say B is equal to, so n into mu naught by 4 pi I 2 pi a square plus x square power 3 by 2. Okay. Generally, I like to remember this separately, so it's easy to remember it like this. A square So is it? So maybe take it down. So it's the same term what you have written there. Only thing you are multiplying by capital N, number of terms.